Hello, my name is Marius Fourie. I'm from Greenpower Consulting, and today I want to talk about what I believe is the optimum configuration of a Victron system to optimize the usage of the energy coming from PV panels and at the same time have a backup system. Now you will notice that I am not going to be using the Victron essential and non-essential outputs. I'm only going to use the Victron essential outputs because I believe that there's a better way of providing power to your non-essential outputs than you currently have with the Victron systems. Okay, so let's look at the diagram that I want to use to explain it. First of all, you have power coming in from the street. That goes through an energy meter, which we'll talk a bit more about. This is a third-party meter that Victron supplies, and that is extremely well integrated with the Victron system. This is the heart of the system, which is the Victron Multi+2, capable of taking AC input, charging the batteries, taking battery power and providing that to your essential loads in this configuration, and also capable of pushing power back, which we'll talk a bit more about. Then there is the Victron MPPT controller, as we generally call it. Essentially, this is a converter that takes power from the PV panels. It converts it to the battery voltages and currents and sequence in which you are supposed to be charging batteries. So it takes the PV power and supplies them on the battery bus so that the batteries can be charged using PV power. This is a central controller of the system. You can see, most important, it's connected to the internet, which means that you can watch the performance of your system on the internet. It's connected to the MPPT controller, it's connected to the Multi+2, it's connected to the batteries, and it's connected to the meter. So it controls everything in the system as if it is a single unit. And that is what makes the Victron system behave like a single integrated system, although it is actually independent components. The nice thing about the independent components is that on all of these you can double up. You can probably, on the batteries for example, I think nowadays you can go up to 16 times 6. There you can have, I don't really know if there is a limit, there you can have I think 6 or maybe 6 per phase. In any case, you can double up on these things and expand your system in the dimensions that you require. Okay, let's look at the essential loads. These are the loads that don't draw a lot of power, but they irritate you if you don't have them, like LED lights, electronics like TV decoder, PC and a laptop, your alarm systems, which is of course an essential electronic systems. All of these draw very little power. Then there's a garage door, draws a bit more power, but you use it for 5 seconds at a time. And then fridges and freezers. Be careful, old fridges and freezers are not energy efficient and they draw a lot of power, but new energy efficient fridges and freezers you can put on a backup system. Right, here's all the heavy consumers. It's things like geysers, stoves, kitchen appliances that heat, in other words toasters and etc., kettle, you name it. Air conditioners, also a heating and cooling device, although it's quite more efficient than these sort of devices. Pool pump, which runs for long and draws a lot of power. So if you look at this first lot, generally the heating devices are things that you don't want to put on backup. So let's look at sorry. Let's look at the uses or the sequence in which you want to use PV power. The first thing you want to do, this doesn't want to do what I want to do now. Okay, the first thing you want to use the power for is to take it from the panels via the charge controller onto the bus, out and it drives your essential loads. Okay, the second thing you want to do is to take the power from the MPPT controller and you want it to charge your batteries. And then the third thing that it can do is it can take, if there's power left, it can take that power and push it back this way. Now the one thing that the meter does in that case is you can take this power, it can push back, and then of course it drives your geysers, your stove and everything like that. The nice thing about this arrangement is if you connect them here or on this side of the inverter to the non-essential loads, all the power goes through your inverter. And sometimes these things can be rough. That can be 2 geysers in the house of 3 kilowatt each. Your stove can be another 6 kilowatts, so you're up to 12 kilowatt. If you have a tumble dryer running, it adds another 3 kilowatts. So you can have a huge amount of power going through your inverter to your non-essential loads, and I don't like that. That to me is a bad arrangement. But what happens if you push power back here is, first of all, this meter talks to the servo, which, as I said, is a central controller in the system, and it can tell, you can set this the system here, you can't set the meter, you can set the system so that you don't push any power back into the grid. Or you can set it, if you have an arrangement and you have permission from your electricity provider, you can say push back a maximum of, let's say 1, 2, 3, 4 kilowatt, whatever you want to set it to. So you can set your system to effectively block the power so that it doesn't flow past here into the municipal meter. And then what happens is your power from here goes out there and it contributes to the geysers and the stove and everything like that. And let's say you draw 2 kilowatt here, you can have a kilowatt coming from here, and then simply the other kilowatt is going to come from here. So it behaves exactly like a grid-tied system on this portion of the system. You effectively have a grid-tied solar system, and on this side of the system you have a backup system. Then of course when you go on to if you lose your power, like in South Africa where we have load shedding, then this part of the system will just fall away and your battery power will only be going to the essential loads. I'm talking about at night. Of course, if it's during the day and you lose the power here, you can still push power onto your essential loads. If there's power left, it will charge your batteries, and it will not, if I'm correct, it will not push power in this way, because this is a grid establisher for this side of the circuit that you establish. So that to me is the way that you optimize your Victron system configuration so that you effectively end up with an integrated grid-tied system plus a backup system. Okay, so Marius Fourie. As I said, I'm from Green Pro Consulting. You can see my phone number there. If you want to ask me any questions or you want to understand how you actually configure, because there's of course another day that we can talk about how do you actually configure this to work optimally. We've just covered this at a very high level, but this is essentially the architecture that I prefer.